I think what needed to be fixed is kind of is more of like macro kind of evolution, where there really hasn't been anything kind of unique or new in the motor world. And as we move towards, as you opened up with Tim, like sustainability, electrification, that requires a more exacting and a more nimble type of offering. And through software, we're able to leverage printed circuit board manufacturing and create very exact motor specifications and motors for end use applications, which allows innovators and engineers to kind of solve problems very rapidly.
It's interesting, and you shared with our producer some research, but the need, and there's a line in some of the background material that you sent, the need for specialized electric motors is an overlooked technology trend. The world was required or will require billions of specialized motors annually in every vertical imaginable in a sector valued at over $200 billion a year. So money talks in our investing audience. One of the things we always like when we have a guest on is like, tell us why they should care about what you are doing. What is it that they need to know and understand?
I think it's the disruption that's going to occur. I think big motor OEMs and there's always going to be a place for traditional motors there where you order through a catalog or you order through a specification. But when you have, the emergence of the internet, the emergence of new kind of fast speed chips, and people innovating very quickly, they need that response time. And in order to fulfill that, that's where ECM comes into play. And the analogy would be in the music industry, when the Beatles and the Stones were recording, they were using 8 tracks and 16-track recording. And now you have artists that are doing everything on their laptop, right? And they're all doing that through software. And that's really kind of that turned that industry upside down. And even at CES, that opened up our eyes. I mean, our booth was just jam-packed for 4 days straight. And we had everyone from large, Fortune 100 companies that were there kind of kicking the tires to what I would call one-off, like, consultants and engineers that are looking for new ways to get their robotics, startups off the ground and their medical device companies off the ground. So ECM's PCB Stator tech enables that. So it's a powerful kind of disruptive tool that I think is going to really kind of turn things upside down.
And is the tool software?
Yes, sir. Yeah. So the software allows users to do exact specifications for what they want for a physical motor, and then the end of the product of the software creates what they call a Gerber file, and that file gets sent to any printed circuit board house in the world, and we're able to print these stators, and then these stators go into mechanical systems that become as a traditional kind of motor that you'd see here. And what's great about that, the ubiquitousness of the software, is that you can print these stators anywhere in the world. So if you have a production facility in Chicago, you can print them right there.
It's so interesting because we talk so much about chips, right? We say chips are in everything, but if it's some kind of mechanical device, whether it's a robot or something else, like you're going to need some type of motor, and that's where you guys come in, right? It's kind of, there's got to be that connective tissue, if you will, and that's what you guys are up to.
Absolutely. That's spot on, Carol. Well, we had a Scandinavian company that makes robotic applications for exoskeletons, and from thought to finish, was 8 weeks, and they were able to put a prototype motor on one of their devices, and actually had an actual patient using it, right? Within 8 weeks. And then they were able to model that and say, hey, we want to have a little bit more torque here. We want to have a little more power. And that direct kind of instant feedback, you can only do that with what I would call dynamic modeling through software.